For example, in a chair production assembly line, when the chair is moving along the production line, a worker notices that one of the legs he is about to put on is too short. If he doesn't put the leg on and changes it for another compliant leg, this is an example of quality assurance. If he continues to put the faulty leg on the chair, and then when another worker at the end of the line tests the chair and has resolved the issue, this is an example of quality control. This system applies both quality assurance and quality control methods aiming to produce an acceptable chair. It is evident that if both workers complete their responsibility, it is unlikely the chair fails to meet the requirement. Hence, successful combination of the quality assurance and quality control can lead to high quality production. However, this system has room for improvement. For example, is the visual inspection reliable? Would introducing one more worker to only check the length of legs make the process more efficient? Reliability, efficiency, and cost are always considered for quality assurance. Types of quality assurance which attempt to balance the trade-off between these are as follows: systematic measurements, comparison with the standard, monitoring of processes, and feedback loops.
An engineering-based example of quality assurance can be portrayed in the construction of a building. To begin the construction phase, materials need to be transported to the required site, where for example a steel beam. But before the beam can leave the factory, systematic measurements must be undertaken to ensure that the beam is of adequate length for its design purpose. To stabilise the construction and maintain its shape whilst withstanding outside forces, the required beam must also have the required strength. This required strength must comply with standards and design to eliminate failure. It's important to ensure specifications including length, strength, and orientation of the beam are satisfied by quality assurance in the construction industry due to the nature of work. The correction or replacement of certain components after the completion of the project can be practically impossible or costly. The transportation and storage for construction materials can cause abrupt halts in the construction process, which may require special attention, where other materials may be cast in situ for immediate use after production, thus eliminating such issues. Monitoring of processes in this case refers to the lifting of the beam into its required position. Monitoring this process will ensure it is placed in its adequate position, and if something were to go wrong, then it can be altered during that instant, then and there, instead of having to adopt another solution, hence wasting time and money. Maintaining an effective relationship with a client is a high priority, and ensuring that they are kept in the loop will ensure confidence and trust in the relationship between client and project manager for an effective outcome. The involvement of numerous professions such as designers, engineers, workers on site, project managers and manufacturers can cause chaos in communication without detailed planning and suitable management. The process of quality assurance in this example is widely accepted in the practice, and therefore reliability, efficiency and cost are optimized in each process. However, this process is heavily based on communication and can be vulnerable to any misunderstandings. A continuous feedback loop between the project manager, designers, workers on site, engineers, manufacturers and client will ensure the overall outcome is fault and problem-free, thus being erected in a time and money efficient manner. In summary, for management of a collaborative project, detailed plans, documentation and consideration for any possible cause of failure should be implemented systematically for quality assurance.
Another example of quality assurance is in a potato chip factory. For better chip quality, a special variety of thin-skinned potatoes are required, of which quickly go rotten in the heat. To ensure quality, this potato goes through numerous checks throughout its journey to the packet, and under a time restraint the potatoes have to be picked and put through shakers and sieves to remove dirt and stones. The potatoes are then washed before grading tables are used to remove green and rotten produce. After the bad potatoes are removed, the remaining are put through a hydro cooler to reduce their temperature and extend their lifespan before being sent to the factory. Once arriving at the factory, the potatoes are rechecked for green or rotten potatoes, size and temperature, assuring quality. The core temperature is essential as it gives an indication of how long the potatoes will last. Another factor taken into account on the intake is the density of the potato. This impacts the amount of time required in the fryer, ensuring the quality of the chip remains consistent. An inspector stands on the line, removing any foreign matter and potatoes that don't meet requirements. Ensuring potatoes are of the best quality stops the snowball effect of defected chips and waste down the line, as each potato produces numerous chips. Once sliced, a laser system scans each chip, looking for brown patches and removing those detected using air jets. These chips are seasoned before being transported to packaging using shaker tables rather than a series of conveyor belts, as this helps keep the chips in one piece. All these steps ensure the product comes out as consistent and higher quality as possible. In food production, the quality of material and consistency of product can contradict. This is especially the case for raw materials that are harder to control. Quality assurance takes place in the form of repeated selections and modifications. This can be highly efficient, as regardless of the variation of the features of materials, modifications can make the faulty parts easier to be spotted. Moreover, the process can be applied regardless of change of raw material. In this case, no matter how low the quality of the potatoes in the farm are, the output through the process can be of a high standard. The endeavour for a flawless chip ensures the use of genetically perfect potatoes causes extra headaches during the production process. This potato leaves a little margin for error from the ground to the packet, which begs the question of, are you best off with a high pressure, high reward system or a low pressure system that allows errors in scheduling and production breakdowns with little waste for less production? In civil engineering, similar ideas for quality assurance are also used. Not all materials are man-made, and the specifications of some natural materials are extremely variable. Soils and stone are frequently used in construction, and the process of repeated modification and selection can also be useful. Through this selection, a positive outcome can be ensured, much like production of the chip.